So as a review, we're just graphing sine. Yesterday we did the noodle graphs. You guys remember that? And when we did our noodle graphs, we were using a unit circle. And so on your unit circle, you can look at 0 degrees, 90 degrees, 180, 270, and 360, and tell me the y values for each of those. And when you do that, you get 0. And for 90 degrees, you get 1. For 180, you get 0. For 270, you get negative 1. And then for 360, you get 0 again. Connect the dots. This is what you get. This is what we got yesterday with the noodle graphs. All right, but what about these other angles right here? We're going to do the same thing. We're going to look at the quadrantal angles, the negative 90, negative 180, the negative 270, and the negative 360. So still looking at your unit circle, the difference between this one and the ones that we just did is that this one you're going backwards. So your graph would look something like this, or your unit circle. Which way do I go to go negative 90 degrees? Counterclockwise. So I would be right here, right? Do you guys know the coordinates for that point right there? 0, negative 1. So what is the y value? Negative 1. So I'm going to put a negative 1 right here. What about negative 180? What are the coordinates for that point? Negative 1, 0. And the sign is y value, so we go 0. And then what about the next one, negative 270? That would take us all the way to here. The coordinates for this one would be 0, positive 1. So we're going to go up to positive 1. And then the last one, 360, will take us back to where we started at the very first coordinates, which is 1, 0. And so your graph looks something like this. Shebang, doogity-doo. There you go. Now you can answer these questions. Well, like this one. What are the relative minima of the sine function? Here's our sine function. Minima means the bottom, right? So these ones are the minimums of this sine function. I mean, on this graph that we see. So you would write negative 90 and negative 1. That's negative 90 degrees. And then what's the degrees for the other one?
Negative 270.
270. And what's the y value for that one?
1.
Negative 1. Right here. Just down there. So those are my minimums. For the maximums, you're going to use 90 and 1 and negative 270 and 1. And this one says right here, for what values of theta is sine theta equal to 0? See all these x-intercepts? That's where sine theta is equal to 0. You could also think about your unit circle right here and look at the coordinates where the 0 is the y value. So I see one right here, which is 180 degrees, which agrees with my graph at 180 degrees. And if that one's 0, then that means 0 and 360, which is right here. The coordinates for that one is 1, 0. The y value is 0 for that one too, which agrees with our graph. At 0 and at 360, we have x-intercepts. Okay, so there's one more question on here that I want to talk about, and it's letter F. Letter F says, okay, to make these, arrange these from smallest to largest, you need to know their values. Now, these angles are all weird, and the reason why they're all weird is because they're not on our unit circle. So there's two ways to look at this. There's two tools that you can use to find out which ones are the smallest and which ones are the largest. The first way to do it is to look at your unit circle. If I look at my unit circle, I can guesstimate where each angle is, like negative 170. Negative 170 would be right about here.
That's not negative.
Oh, thank you. Like positive 170. So positive 170 would be right about right there. The distance from the x-axis to the point is sine. So it would be a positive small distance. This is 170. And then we have 85. 85 would be really close to 90 degrees. Do you guys see that? 85? And then we have negative 85, which would go the opposite direction. Not a full 90, just negative 85. And then the last one is 200. 200 would be right here, right after the 180. Okay, so if I were to range these from smallest to largest, I would first start with the negative 85, because that would be the biggest negative number. So that number should be first. Sine of negative 85 degrees. Then the next one should be the other negative number, which is positive 200 degrees. Sine of positive 200 degrees is negative because the distance from the x-axis to that point is going down. So we're going to write sine of 200 degrees. That one is the next biggest one. And the next biggest one after that one, which one is going to be the next biggest one? The distance from the x-axis to 170 or the distance from the x-axis to 185? 170 would be next. So you say sine of 170 degrees.
So it's pretty much easier if you graph it.
Oh yeah, totally. Way easier if you graph it. So I'm looking at the unit circle to do this, but you can also look at the graph that we had earlier. Okay, let's check out the graph we had earlier. Here's our graph again. I think the first one was 170, right? 170 is right about right here. That's 170 degrees. And then the next one was 85. 85 is right about right here. Way up there. And then what's the next one after that? Was 200 next? I think 200 was next.
No, yeah.
So 200 is going to be right about right here. That's 200. And the last one, let's put 85 right here. It was negative 85, so that would be down here. Okay, so if I were to list these smallest to biggest, I would start with the sine of negative 85. That would be the smallest because that's the most negative. And then it would be sine of 200 because that one's still negative, but it's smaller than that one. I mean, like, the distance is smaller, so it's not as negative as that one. Then 170, then 185. So you just go from the bottom and up, and that will give you smallest to greatest.